All right, so in this section, we're going to start talking about classes and the way they're implemented in Kotlin. And we're going to begin by looking at class properties. So I'm going to make a class called person. And now I want this person to have both a name as well as an age. Well, the definition of these properties, and notice these are properties rather than fields, is going to look something like this. I'll have var name of type string, and I'll give it a default value of an empty string, and I'll have var age, which is of type int, having the default value of -1. Now, there are a couple of things to note about what's happening here. So first of all, the initial values are mandatory because remember, these are non-nullable types. The other thing that's worth mentioning is they're both var because we want to be able to change them at some point. So these are not actually fields. They are properties, which means that essentially they do have a backing field, but they also have getter and setter functions that you actually invoke. But if you don't specify those functions, then it feels very natural. It feels almost as if it was just an ordinary field. So let's try using them. I'm going to create an instance of person, so I'll say val me equals person. By the way, notice there is no new keyword, as always. And then I'm going to initialize the name and the age. So I'll say me.name equals my name, me.age equals 123. And now what I can do is I can maybe print this out. Now, next up, what I might want to do is I might want to determine whether this person can vote or not. Now, for this, instead of making a member function called canVote, we're going to make a property. So I'm going to define a property called canVote, which is of type Boolean. And notice this is going to be a read-only property. It's not going to be a property that you can assign a value to, but you can get a value. And the result of the ability to vote is whether or not the age is greater than or equal to 16. So what can we do with this? Well, we can print it out, for example. So what I can do is I can print line as follows. So I can say, for example, that me.name, Dmitry in this case, can or cannot vote. So the determination of whether I can vote is done using this particular property, can vote. So essentially what we can do here is we can put a dollar and the curlies, and here I can say if I cannot vote, if not me.can vote, then we're going to add the word not. Otherwise, we're going to add an empty string. So this essentially calls the getter of this property. And as you can imagine, if the property has this kind of form, it really does have a backing field. So there is a backing field out there which also gets used in the generated getters and setters. However, if you have a property defined as this, it does not have a backing field. It simply acts not as a function but as a property, but actually invokes the getter and gets us the result. So let's actually run this function now. All right, so with the age of 123, I can vote, and if I change the age to just 12, then I cannot vote. Okay, so obviously these properties have automatically generated getter and setter functions, but you can always define your own. So let's take a look at an example of how this would work. What I'm going to do is I'm going to make a var called SSN, and I'll have a couple of zeros in here to start with, and then I'm going to define the getters and setters. So whenever somebody wants to get the social security number, all we're going to give them is the value of the backing field. And to get the value of the backing field, you can use the field name. So field refers to the backing field. Now let's suppose that in the setter, I want to have something more than a one-line expression. Let's suppose that I also want to notify somebody that the social security number has been changed. So I can print line here, for example, that this person's SSN has been changed, and then I can set the value. So then I can set field equals, and then the value that's set should actually be an argument. So it should be a parameter here. So we set the value and we assign the value that's being set to the backing field. Okay, let's take a look at how this would work. For example, if I say something like me.ssn equals 1, 2, 3, 4, 5, 6, 7, for example, and I run this, what really happens is because we're doing a set, here it is. Dimitri's SSN has changed because essentially we took the value that's being assigned, and that was the value that's output here, and then we notify that the SSN has changed, and then we assign the value. So the getter and the setter, if you do decide to write them by hand, you can perform all sorts of validation and various things with it. Now, one thing you might find a bit inconvenient is the fact that we had to initialize the properties. So maybe you want to leave properties uninitialized. Now, in most situations, you would initialize the properties not even like this, but put them in the primary constructor, which we'll talk about in a moment. However, if you really must leave a property in an uninitialized state, you can explicitly tell the compiler that you want to do exactly that by using the late init keyword. Now, what happens here with late init is you no longer have to give it an initial value, so you can get rid of the initial value here. However, what this lets you do effectively is avoid putting in the initial value, and you can try assigning the property later. However, what would happen if we try to print out the name before assignment? Well, let me show you. Printline me.name. Let's actually run this. So now we have a late initialized property that hasn't been assigned a value yet, and as you can see here, we get a Kotlin uninitialized property access exception, which tells us exactly what went wrong and where.